student won $500 in an art contest. At first, the student kept the money in a desk. After 10 months, the student deposited the money in a savings account that earned interest. 6 months after depositing the money, when t equals 6, the amount of the account is given. 12 months after depositing the money, when t equals 12, the amount is given. They provide us a piecewise function where m of t is the amount in dollars at time t since the 500 was just deposited into a savings account. A negative value for t represents the number of months before the student deposited the $500 into the savings account. Let's get started with the first one. Part A has two parts to it. The first part says use given information to write two equations that can be used to find the values for A and B. So let's go with what we know. We know m of 0 equals 500. Let me come back to this other side. I'm keeping this in mind, okay? We know that m of 6 is 508.67, m of 12 is 517.50. So this is that given point t. This is the time after the $500 is positive, and then this is the amount in the account after you've earned interest. Okay, so let's start with the first one. We know m of, okay, let's go with 0. So m of 0 equals a times b raised to the 0 divided by 12. And we know m of 0 is equal to 500. So 500 equals a times b raised to the 0 divided by 12. One equation. I'm going to write these all down. Now we have m of 6. That doesn't work. M of 6 equals a times b. And again, in this position, I'm plugging in 6. So 6 divided by 12. Now m of 6 is 508.67. Okay, let's do one last one here. We also have m of 12 equals a times b raised to the 12 divided by 12. Now m of 12 is really 517.50. So I'm so sorry you couldn't see those. So I've done my 3 different equations. Let me zoom out to make sure I don't make that same mistake. The second part asks us to find the values for A and for B. So if we come up here, we can see, so this is part 1. Now part 2, we're going to find the values for A and B. So I'm going to take this equation, 500 equals A times B. Well, 0 divided by any number is 0. And I know that any value raised to the 0 power is 1. So 500 equals A. 500 equals A. Now how can I use that A value in order to solve for B? I'm going to take the second equation. We could use the third as well, but I'm going to take the second equation and write this down. We have 508.67 equals, hi, A, well, A is 500, so 500 times B raised to the 6 over 12. 508.67 equals 500 times b raised to the 1/2 as I reduce this. Let's divide by 500. And now how do I isolate the b? I'm going to raise it to the reciprocal, which is 2 over 1, or simply 2. Let's grab that calculator and let's plug this in. 508.67 divided by 500, get an answer, and then we're going to raise it to the second power, or 2 divided by 1. So b is approximately 1.03, rounded up, 5. Remember, 10. Remember, don't circle your A and a B. It'll negate the work that you're asked to show. Let's move on now to part B. Let me flip this over. What is part B asking us to do? Let me get this nice here. So in part B, we are going to be asked to do the following. So part B says use m of 12 and the average rate of change. Oh, sorry. Part A the first part of B says, use the given data to find the average rate of change of the amount of money the student has in dollars from T equals -2 to T equals 12. Okay, so how do we find the average rate of change? Well, there's a couple different ways we can do it. Let's start by writing down this equation. We now know A is 500, and we know that our B value, I think, was 1.035, but let's make sure that's correct. 1.035. Okay, and that's going to raise to the T divided by 12. So this is my equation. I'm going to take it, I'm going to come up here and plug this in. 500 times, make sure to use that parentheses. And again, parentheses around the fraction that's in the exponent position. Okay, let's open up this window and do a zoom cut. Okay, so we want to find the average rate of change. So we're asked to show our work. So we're going to go the output value when m is 12 minus the output value when m is -2 over 12 subtract -2. Okay, at 12 we have 517.5. At -2 we have 497.14. And dividing here. Okay, so we have approximately 1.454 is the average rate of change, and we'll write this in just a second, the context. So before I'm writing down my answer, what I'm thinking is this represents the amount of money the student has prior to them actually depositing it. So if you think of T equals 0 is when the money goes into the bank. Now, prior to that, it said that they still had money, but they kept it in a desk. In fact, they kept it in a desk for how many months? The student kept the money in the desk after 10 months. So 2 months beforehand, they didn't have this amount of money. They still had $500. So I'm going to come back and I'm going to change this. This is what the graph says on here in the calculator, but it's not realistic because we know before T equals 0, they would be flat at 500. Then they start to gain money. They're never losing money before that point. They're just not gaining interest. I'm going to change that to 500. And let's do this again. 512 or 5.17.5 subtract 500 and divided by the 14. There we go. I like that much better. Okay, so we have exactly 1.25. That's going to be my average rate of change. So this is the amount. Okay, let me go back here. It says estimate the amount of money in dollars the student has. Oh, sorry. Given the data, what is the average rate of change in the money in dollars from months? Okay, this is the average amount of money gained because it's positive, per month from 2 months prior to investing the money in a savings account to 1 year after the money was invested in a savings account. Let's go on to the second. Okay, let's move on to the second part here. The second part says we're going to use this average rate of change in order to basically create an equation. And then after we create that equation, we want to find out when T equals 20 from that. Okay, so what I know is I have these 2 points, right? So I'm going to write these as ordered pair. I have negative 2, 500, and I have 12, and I want to create a linear line. I want to create a secant line from negative 2 all the way up to 12. What I can do here is I can clear my calculator, and I can plug in these 2 points. So negative 2 and 12. And this will create it for me. Now, what I do need to share is I need to share with the AP reader what I'm doing. So I would write using a linear regression model. Okay, so I'm going to go up to stat, go over to calculate, go all the way down to this one, and we can see that the A goes with, and we can see the exact same rate of change that we had up above, which makes me feel confident here. It's y equals, I'm going to say, yeah, let's just do it. Y equals 8x plus b, y equals 1.25x plus 5 of 2.5. I can move that up so you're able to see everything. And now it says, using this equation, they want us to calculate m of 12. So this is let A of t is the estimated amount of money the student has using the average rate of change. So we're going to call this the average rate of change, specifically, so A of, and they want us to calculate 20. So I'm going to take this a couple different ways we can do it. One of the easiest ways is literally just to plug this in. That looks good, and we get 527.5. So using the equation from the average rate of change between t equals negative 2 and t equals 12, A of 20 will equal 5. Okay, let's go on now to the third part of. Okay, let's look at the third part for part B. So part B, we're on the third section. Let A of t be the estimate of the amount of money and dollars a student has for time t using the average rate of change found in the very first part of B. In the second part of B, A of 20 was computed. If A of t is used to estimate the values for m of t for all values greater than 12, and error in estimates will increase as t increases. Explain why this is true. Your explanation should include a reference to the graph of m and its relationship between the estimates found. Okay, so what we're going to do is we're going to use exactly what they said. We're going to use our graphing calculator. So let's come up here, and what we need to think about is this particular function. Remember, it's going to be 500. Now, we are going to put this in a piecewise function. So it's looking like something like this. This is when the person does not estimate the money, and then when t equals 0 represents the time after the money was invested in the savings account, and then it turns into this exponential function. So t, we're going to divide it by all x values that are less than 0. So how do we find a less than? You're going to go up to math, and let's see. Maybe actually I need to do second test. Let's go back there. There we go. And so I'm going to go down to less than 0. Press pause and get that down in your calculator. Now, anything that's greater than or equal to 0, we're going to use this equation. So 500. We know what the b value is. I put b here. We know b was 1.035, and it was an estimation we estimate to the roundest thousand. So 1.035 raised to the t divided by 12. Now what I want to do is I want to take this entire thing and we are going to divide it by, so let me insert this and I'll give you a chance to catch up. Oh, I lost that. Let's go insert 500. Okay, we got that. So that is the function. We only want that function when t is greater than or equal to 0. So we're going to divide by, and we're going to put down that statement. So T, we'll use X here, and then we're going to hit second and go down to math. Oh, second, math, I hit the wrong one, and we want greater than or equal to 0, and we should be able to see this function. Let's look. We're going to have to adjust the window. We'll absolutely have to adjust the window. So let's go out to 50 and do a zoom fit. We do not need to go that far. Let's try this again. Let's try this again. Let's go to Windows. Let's go out to 30. And let's go all the way down so we can see everything. Make sure we can see everything. Okay. So this person, the student is gradually earning money in a savings account. It's going to exponential form here, but gradual. Anything to the left of 0 is going to be constant at 500. And remember, that's 10 months leading up to the 10 months leading up to it. So actually, I'm going to go back and change this to be accurate. This is not just less than. This is it's from 10 months. So I got to go back and change what this looks like. This is going to be. I gotta think of the best way to write this as a combo function. So X is greater than or equal to -10, and then we're going to go back to that test and go to the logic, and X is less than 10. So between, I forgot the number there. There we go. So from -10 all the way up to 0, but not including 0, it's going to be at $500. The first 10 months they had this $500 and it wasn't invested. And it'll look like this. And if I go far enough to the left, let's go to -15, you can see that. So here's where $500 was invested, and it's gradually growing up with interest. Okay. Next, I'm going to now plot this equation, which is this average rate of change that was created. So 1.25x plus 502.5. So this is going to be from -10 to 0, and then this is going to be gradually anything greater than. Now let's zoom in here and get a better look at this. So let's come up here and let's say from 500 all the way up to maybe 590 and see if we have a better view of this. Okay, so this is the first function, and here is the second function. The black line is that average rate of change that we created. Now this question says when x equals 12, so that's after 1 year. Okay, so x equals 12. Where is x equals 12? Let's see if I can get in here. The value at 12. Maybe I have to go here. Thank you for your patience while I look at this graph of the table of values. There we go. Okay, so here we go. You ready? This is going to be my average rate of change, and this is going to be M of t. Average rate of change, A of t, and M of t. And it says an error will increase as t increases. So as we go down, we're going to see more and more of a difference here. You can see they're equal at 12, and then we can see that gradually we can see that this value here representing our A of t, our average, is going to be slightly less, and we can see that's consistently slightly less. And in fact, the difference increases as t increases. Okay, give me 1 second. So maybe we do want to come up here and we will show how I'm going to use a different color here. Let's see what stands out. So we're going to say this is where they're equal, and it's looking like this. So this is A of t, and this is M of t. Okay. And so we're asked about the error. Okay, here we go. So the error is the difference between A of t, which is the estimated value, and M of t, the the savings account. Okay. After t equals 12, 1 second. I'm sorry, let me move this up here. After t equals 12, in which both functions have the same output value. And we can see that, I'm so sorry here. We can see that right here. If I go second table, we can see at 12, they have the exact same output value. And that's how I was able to see that. Okay, so let me go back here. I'm sorry, I'm getting in messages. The error is the difference between the estimated value and the actual value in the savings account. After t equals 12, in which both functions have the output value. Black, oh my goodness. Thank you for your patience while I mute those messages. So after t equals 12, in which both functions have that same output value, the function a of t lies under the function m of t. M of t is concave up after t equals 0, and the output values for m of t will always be greater than a of t when t is greater than 12. Let's go on right now to, and remember it's important to give as much information as even tells us to use the graph, so I draw a graph and share this. Let's go into part C. The student plans to choose an account when the amount of money in the account reaches $565. Explain how this information can be used to determine the domain of limitations for M of T. So we want to know, when is this account going to equal the actual M of T? So I'm going to take out this A of T, which is estimation, and so we can see this basic equation here, and we want to know when is this going to reach a value of 565, in which the account at that time will close and they'll decide what to do with the money. So let's go over here and find out, when does it equal 565. Let me graph this. And we can see we didn't go up far enough, so I need to expand this out further. Let's go up to 50 and see it, just estimation to see if is that far enough. So letting the AP reader know what I'm doing, this is part C. I am graphing y equals 565 and finding the intersection with M of T equals 500 times 1.035 raised to the 12, T divided by 12. And this is with T greater than or equal to 0. Because remember before that, between negative 10 all the way up to 10, all the way up to T equals 0, we would just have a straight 500, and you can see that right here. So let's figure out this intersection point. Let's find this intersection point. Where is my graph? There it is. Okay, boom, boom. And here we go. So this is my intersection. So I can say that when M is 42.632, we have an output value of 565. This is specifically the main limitations. So we can say that we have, it goes from negative 10, we include that, that's when this person earned the money, and then it will stay within the account that we created all the way up to 2.632. At that point, the account will be closed.